In this video, we're going to do a couple of extra examples, finding the zeros and factoring polynomial functions. So first, as promised, just to remind you, so in example 1 here, we wanted to divide f of x by the factor x plus 2, which we completed using synthetic division, but I'm also going to do it with long division, in case you want to see that. So I have x plus 2 divided into 2x squared minus 3x plus 1. So I take the biggest power here and I say, what do I need to multiply this by to get this one? So what do I need to multiply x by to get 2x squared? And that is 2x. And then I take that thing and I multiply it to both parts here. So that's going to be 2x squared plus 4x. And then I want to subtract both of those things. So 2x squared minus 2x squared goes away. But then I have minus 3x minus 4x is minus 7x. And then the plus 1 comes down. And then I do it all over again. So what do I need to multiply x by to get negative 7x? Well, that's negative 7. So then I take the negative 7, I multiply it to both terms. So that's negative 7x minus 14. And then I want to subtract both of those. So negative 7x plus 7x cancel out. And then I have 1 minus negative 14. So plus 14 is 15. Now here I know to stop because the degree of this is less than the degree of the divisor. Okay, so that's where I stop. This thing down here is the remainder. And the polynomial up here is the quotient, which is the exact same as we got the other way when we used synthetic division. So we also saw that the remainder theorem says that if we try to divide f of x by x minus c, then our remainder should be f of c. So doing this example, if I want to find the remainder when I divide this polynomial by x minus 3, all I need to do is evaluate f of 3 according to the remainder theorem. So remainder is going to be f of 3, which is going to be 3 cubed plus 3 times 3 squared plus 2 times 3 minus 5. So that's 27 plus 27 plus 6 minus 5. So I get 55 in total. Okay, so that's f of 3. So that means here that the remainder is 55, according to the remainder theorem. Now, if f of c is 0, that means the remainder is 0. That tells us that x minus c is a factor of f of x. Okay, so this is one way you can tell whether or not something is a factor, is by finding the remainder, which is by evaluating the function at that value. Okay, so here let's say we want to see, is x plus 4 a factor of this polynomial? So remember, x plus 4 is actually x minus negative 4. So this is our c value. So to check, we just want to evaluate f of negative 4. So that's going to be 4 times negative 4 to the 6 minus negative 4 to the 5 plus 3 times negative 4 squared minus 9. So that is 16,384 plus 1,024 plus 48 minus 9. So we end up getting 17,447, which is definitely not equal to 0. Okay, which means that our factor, or possible factor, x plus 4 is not, in fact, a factor. So it has a remainder of 17,447. Okay, so it's not a factor, so it wouldn't be one of the factors when we try to factor that polynomial. Okay, so now we're going to use the rational roots theorem to factor a fourth degree polynomial. So remember, in order to use this, We have integer coefficients. Okay, so all the coefficients are integers for our polynomial, and the constant term is not 0, otherwise we can factor out an x before we do this. So then all rational zeros are the factors of the constant term divided by the factors of the leading term. Okay, so let's use that to try to factor this polynomial in example 6 here. So we start with possible roots. Okay, so it's divisors of the constant term, -8, over divisors of the leading coefficient, which is 1. So divisors of -8 are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And divisors of 1 are just plus or minus 1. So here we have only integer possible roots. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Okay, so those are our possible roots. So now we just want to check. Keep plugging in until we find one. So maybe we plug in 1. So that's going to be 1 to the power 4 is 1, minus 1 to the power 3, plus 2 times 1, minus 4 times 1, minus 8. So here there's going to be way too many minuses. Okay, this is -10, so nope. Maybe I shouldn't do an x. Okay, so it's not 0. So we try something else. Maybe we try -1. So that's -1 to the 4 minus -1 cubed plus 2 times -1 squared minus 4 times -1 minus 8. So -1 to the 4 is +1. -1 cubed is -1. -1 squared is 1, so this is a +2. -4 times -1 is +4 minus 8. So this is again a plus. So here I actually do get a 0. Yeah, because I have 1 plus 1 plus 2, that's 4, plus 4 more is 8, minus 8. So we can factor that out. Okay, so maybe we do synthetic division. So we want the -1. Okay, and our coefficients are 1, -1, 2, -4, and -8. Okay, so we bring this one down, so that's a 1. -1 times 1 is -1. We add, we get -2. -1 times -2 is 2. We add, we get 4. -1 times 4 is -4, so we add and we get -8. -1 times -8 is 8. We add, we get 0. Okay, so that's good. So this would tell us that our f of x is the factor x plus 1 times, so this was x to the 4. So here we're going to start with x to the 3. So it's x cubed minus 2x squared plus 4x minus 8. Okay, so then we'd want to, so now we want to, let's call this g of x. Okay, now g of x satisfies our conditions. So we want to try and factor that. It has the same, I'm just going to write it here, so the same possible roots. Okay, so nothing was eliminated. So we just got to keep going. So we did 1, -1, maybe we want to do, I don't know, -2. Okay, so that's going to be -2 to the power 4 is 16. Minus -2 to the power 3 is -8. plus 2 times negative 2 squared, that's going to be plus 8. And then I'm going to have minus 4 times negative 2, so that's going to be a plus 8. And then I have a minus 8. So those are going to cancel, plus 8. I think I have 16 plus 16. I think I have 32. Yeah. So then, okay, we want to try something else. Maybe we try positive 2. So 2 to the power 4 is 16. Minus 2 to the power 3 is 8. Plus 2 times 2 squared, that's also 8. And then we have minus 8 minus 8. So here the minus minus. And then I have 16 minus 16. So here I get 0 again. Okay, so that means that x minus 2 is a factor. Or sorry, x minus 2 is a factor because 2 is a root. So I can do my synthetic division again, but I'm doing it on g of x. So my coefficients are 1, negative 2, 4, and negative 8. Maybe I'll just write that. So these are coefficients of g of x. Okay, so bring the 1 down. 2 times 1 is 2. Okay, we add those, I get 0. 2 times 0 is 0. Add those, I get 4. 2 times 4 is 8. Add those, I get 0. Okay, the remainder 0 is good. So this means, so g of x factors as x minus 2 times, so this was x cubed, so this one's going to be x squared. So it's going to be x squared plus 0x plus 4. Okay, so that means that our f of x is going to be x plus 1 times x minus 2 times x squared plus 4. And x squared plus 4 doesn't actually factor anymore. Okay, so this one is an irreducible quadratic polynomial. Okay, so it doesn't factor any further, so that's how we would leave our answer. Now, it's possible that you could factor a different way. So I think for g of x, maybe I'll just do this in a different color. I think for g of x that we could have actually factored by grouping. So if I take out x squared, then I'm left with x minus 2. And here if I took out 4, I'd be left with x minus 2. So then I could have right away factored as x minus 2 times x squared plus 4. Okay, so sometimes there's little tricks. If you get down, you can maybe use factor by grouping to simplify your, to factor your sort of non-quadratic ones. So it's possible, but the method will still work, assuming that there are more rational zeros. So if we wanted to find all solutions to the equation f of x equals 0, then, oops, I'm in pink here. So that means f of x equals 0 means I'm going to use the factored form because it's easier to do when it's factored. So it means the factored form equals 0, which means that one of the factors is 0. So x plus 1 is 0, x minus 2 is 0, or x squared plus 4 is 0. So that means that x is minus 1 or x is 2. This one has no solutions because the x squared is always positive. So if I add 4 to it, I'm going to be something positive. Okay, so solution set here would be the set containing -1 and 2. Okay, so both of those are solutions to where f of x is 0. The x-intercepts, so these have x values with y value of 0. So that means they are solutions to f of x equals 0, which is what we did in B. So that means that the x-intercepts for this graph would be -1, 0, and 2, 0. Okay, so we actually already did all of the work for that. We just need to know that solutions to f of x equals 0 are giving you the x values of your x-intercepts. So that's factoring for polynomials of degree higher than 2.